Okay, part 3 of this series with the mole concept is the hardest of probably all of them. Okay, it's to calculate the number of molecules that you see given a mass of a molecule, atom, ion, whatever. Okay, so the formula is that it's the mass of the molecule times Avogadro's number, that's 6.02 times 10 to the 23rd, divided by the molar mass of whatever it's asking for. Okay, so it wants the number of atoms in 25.7 grams of aluminum. Before we start this, the key that I have to use Avogadro's number is the problem asks or has the word atoms, molecules, formula units, or ions there. Okay, so I'm going to kind of flip back and show you what I mean. So this one you see the word atoms. Okay, if we look back at these types of problems, you notice that this one does not have Avogadro's number, and it doesn't state that. It says moles of substance. It doesn't mention the word atoms, ions, molecules, formula units, or ions. Okay, same thing here. There's no mention of those 4 words anywhere in this question. Whereas the first type of question that we did, you see that while it doesn't ask it in the question, here are the key words. Here's atom, here's molecule, and here's formula unit. So when you see those as any part of the question, whether it's the specific one or in the question itself, that's your cue that you have to use Avogadro's number. Okay? So, now back to this one. Okay, the number of atoms in 25.7. So I need the molar mass. So the molar mass of aluminum is simply 26.98, okay, grams per mole. So I take the mass given, which is 25.7, times Avogadro's number. This is a constant, okay? It's given to you on the formula, not on the formula sheet, on the periodic table that I give you, times 10 to the 23rd, divided by the molar mass of 26.98, okay? And so when I do that, I get 5.73 times 10 to the 23rd aluminum atoms. Okay, so when it wants the number of atoms or ions or whatever, I want a big number. When it wants the mass, I want this to be a negative number. In other words, I want this to be a very small number. So if it gives you atoms, molecules, and asks for mass, it's a very, very small number. If it gives you the mass and it wants the atoms, it's a very, very large number. Okay. More problems on the next page. Okay. This is, since I'm practicing this is dinitrogen, because nitrogen is a nonmetal. Okay, and as a nonmetal, that means this is a molecular compound. So di goes with the prefix of 2. The prefix of 5 is penta, although we don't usually include the A. Oxide. Can't practice too many nomenclatures. Number 1, it will be on every test you take this semester. Okay, so again, I'm going to do the molar mass. Now, I'm going to start shortening this because we've seen it a lot of times. So for nitrogen, I have 2 times the 14.01, plus I have 5 times 16 for oxygen, and I will eventually get to the point that I will shorten that even more. But this is 108.02 grams per mole. Okay, so the formula is I take the mass given, which is 14.9 grams, times Avogadro's number. This is a constant. This is the one. Avogadro's number means a constant means I'm going to use the same number every time, divided by this molar mass of 108.02. And when I do that, I get 1.67 times 10 to the 22nd into 05 molecules. Okay, that's the answer to that one. All right, the next one, let's do nomenclature first. Is it ionic, molecular, or an acid? Well, it's ionic because sodium is a metal. Okay, sodium is a main group metal, so I don't have to worry about the charge. So it's sodium. Okay, ClO4. Well, chlorine is on the 7. That's the 7. Okay, it's on the 7, so 3 should make it 8, but I have 4. So when it's more than 8, that's my cue that this is actually perchlorate. Okay. Molar mass. I have 1 sodium, so it's 22.99. Again, I'm just getting these numbers from this right here. I'm rounding to 2 decimal places. I have 1 chlorine of 35.45. And then I have 4 oxygens, 4 times 16. So the molar mass of this compound is 122.44 grams per mole. Okay, so the formula is I take the mass given, 2.99 grams, times Avogadro's number, 6.02, times 10 to the 23rd, divided by the molar mass of 122.44, and this is equal to 1.47 times 10 to 22nd formula units. Okay, and we have one more problem. It's on the next slide. This one's a little bit more tricky because this is asking for calcium ions in this compound. But I'm still going to start out the same way. First of all, is this an ionic compound, a molecular compound, or an acid? It is an ionic compound because calcium is a metal. Calcium is a main group metal, so I just need the calcium. I don't need the charge. And then PO4 is a polyatomic ion. P is off of the 7, so therefore the 4 simply makes it 8, so this is phosphate. Okay. Molar mass wise, I have 3 calciums, so 3 times the 40.08. I have 1 times 2 is 2 phosphorus, so 2 times the 30.97. So this is the calcium. This is the phosphorus. Plus 4 times 2 is 8 times the 16 for oxygen. And so that gives me a molar mass of 310.18 grams per mole. Okay, and I'm still going to do this the same way. I'm going to take the mass given, 4.71, times 6.02 times 10 to the 23rd, divided by 310.18, and that gives me 9.14 times 10 to the 21st. This is going to be the Ca3PO4 formula units, which is not quite what this asked for. Okay, so you see this was for the whole compound. This is for the whole compound, so I had to calculate this first. But it's asking for just the calcium. So how many calciums are there per compound? And the answer is 3. You see that here, right? So I need to now multiply the fact that there's 3 calciums for every 1 Ca3PO4 2. So I need to multiply this number by 3, and I get 2.74 times 10 to the 22nd calcium 2+ ions. Okay, so I can find it within the compound just as well as I can of the compound itself. All right, and so that's the end of this section here.